Okay, looking at question 20 and, well, both parts of 20. I have a 3s orbital and a 2p x orbital. All right, the question wants us to state the n, l, and m sub l's if we can, and then sketch it. So the n and l's we can definitely do on both these. Like on the 3s, the n is 3, and the l, because of the s, is 0. Now, the m sub l is always dependent on what the l is. It's going to go from negative l to positive l. But since our l is 0, this has a m sub l of 0. So that's what that one would have to be. It's just 3, 0, 0. And being that it's a l of 0 or an s orbital, when I go to sketch it, I'm just going to draw a sphere. Of course, it looks like a circle because I got 2 dimensions. All right. The next one we're doing is a 2p orbital with that little x. Now, I'm actually going to ignore the x because we're not going to try to assume the particular orientation. I'm going to cover it here in our explanation, though. But the 2 and the p tell us our first 2 quantum numbers. The n has to be 2, and the l, because that is a p, has to be 1. Now, because of that, our potential l's could be negative 1, 0, and 1. So I'm going to put them all there. So this particular one technically has 3 potential answers. But what the x kind of says, it's not any one of those, it's not all 3 of those, it's a specific one. So we could kind of arbitrarily say that a 0 is the x and the positive 1 is a y and the other one is a z, but we never actually did that in the quantum theory world. All we're able to say is if I define one as x, then it can't be y or z. But I didn't do enough to define this. So I kind of have to leave this particular one answered this way. The answer is one of these. But we really don't know enough to tell which one. All right, and then to sketch a p orbital, we're just going to have a figure 8.